Hello everyone, welcome back to TechOps tutorial. In today's session, we are going to look at an important topic in Kubernetes, that is ReplicaSet versus pod. A lot of beginners get confused here. What exactly is a pod and what is ReplicaSet and why do we even need both? So in this video, we will break it down step by step. First, we will talk about pods. Then we move on to a ReplicaSet, and finally I will show you a quick demo so we can see the difference in action. By the end of this video, you will clearly understand where to use pod directly and where ReplicaSets makes more sense. Now let's think about pod for a moment. Imagine you are running your application in a pod and suddenly the pod crashes. What happened then? Do we have to manually restart it every time? That does not sound reliable, right? Especially if you are running a critical application on production. And remember, pods are designed to be a short life, so using just pod in a production can be risky. This is exactly where ReplicaSet comes in. A ReplicaSet acts like a supervisor. If one pod fails, it immediately notices and create a new one to replace it. So instead of us worrying about keeping pods alive, ReplicaSet handles that automatically. Before we dive into ReplicaSet, let's do a super quick recap of pod. Pods are the smallest deployment unit in Kubernetes. They usually run one or more containers that shares the same network and storage. Think of a pod as a wrapper around your containers. It gives them an IP, storage volumes, and let them talk to each other easily. Since I have already covered pods in detail in my earlier video, I will keep it short here. If you missed that one, make sure to check it out. I have linked it in the description. Next. Alright. So let's talk about what ReplicaSet is in Kubernetes. ReplicaSet is like a manager that keeps an eye on your pods. Its main job is to make sure a certain number of pods are always up and running. For example, here we have a set to desired number of pods to 3. The ReplicaSet keeps checking to make sure there are always 3 healthy pods. Now, if one of the pod fails, like this, a red one here, the ReplicaSet notices it and quickly replaces it by starting a new one. This feature is called self-healing, which means it can recover on its own without us needing to do anything manually. In short, ReplicaSet helps keep your app stable by making sure the right number of pods are always available. Now let's look at the difference between pod and ReplicaSet. Starting with pod, these are the smallest unit in Kubernetes. You can think of them as a basic building blocks that runs your application. Pods are ephemeral, meaning they don't come back on their own if they crash. Also, a pod usually runs just one instance of a workload. There is no built-in replication with a single pod. Now, on the right side, we have a ReplicaSets. A ReplicaSet manages the multiple pods. It acts like a supervisor that makes sure you always have the right number of pods running. It also has a self-healing features, so if pod goes down, the ReplicaSet will automatically spin up a new one to replace it. So in simple terms, if pods are the workers, the ReplicaSet is like the manager, making sure there is always enough workers on the job. This slide explains a very important concept in Kubernetes, the difference between desired state and the current state. On the left, we have a YAML file. This is how we define the desired state using the code. Here we are saying we want 3 replicas of pod running a web application using the Nginx image. On the right side, we see the current state of system, which shows the actual pods running. Now here, where the controller comes in, it keeps checking if the current state matches the desired state. So if only 2 pods are running but we asked for 3, it automatically creates a new pod to match that. This process is completely automated. Kubernetes is always working behind the scene to make sure what's running matches what we have defined. Let's talk about why we should use ReplicaSet in Kubernetes. First, high availability. ReplicaSet ensures your application is always available. They automatically recover from failures, provide fault tolerance and minimize the downtime. So if something goes wrong, your application stay up and running. Next is scaling application. With ReplicaSet, scaling is easy. You can scale your application horizontally, meaning you can add more instances to handle traffic spike. Plus, it helps with load distribution across instances to ensure smooth performance during heavy usage. Finally, foundation for deployments. ReplicaSets from the backbone of Kubernetes deployment. They are the building blocks for rolling updates and ensure that the deployment is managing your ReplicaSet effectively. In short, ReplicaSets gives you a reliable and scalable foundation for your Kubernetes application, keeping things running smoothly and resilient to failures. Here is an important note to keep in mind. We usually don't create a ReplicaSets directly. Instead, we create a deployment which manages the ReplicaSet for us. The ReplicaSet in turn manages the pod. So the flow looks like this. The deployment manages the ReplicaSet and the ReplicaSet manages the pod. This structure allows us to easily scale and update your application. It's also important to understand how ReplicaSets works before diving into our deployments, because they are the foundation that makes deployments work seamlessly. Okay, now that we know the structure, deployment manages the ReplicaSet and ReplicaSet manages the pod, let's jump into the demo. Here is our agenda for next few minutes. We have 4 quick steps. First, we will create a standalone pod using a single command and prove that when we delete it, there is no auto recovery. Next, we will create a ReplicaSet with 3 pods, defining the desired state using a YAML file. Then we will demonstrate the core concept. We will delete one of the running pods and watch the ReplicaSet automatically creates a new pod to maintain the count of 3. This is the self-healing features. Finally, we will scale the ReplicaSet from 3 to 5 with one command to show how easily scaling is possible. The key highlights we are looking for are pod recovery, self-healing and scaling. Let's get started. So we will start a MiniKube first with the driver-docker. Driver equals to docker. This will take 1 or 2 minutes to get started. Check the MiniKube status. Verify cluster is running or not. So before we start our demo, let's clean up the leftover resources which we created in our past demo. -all namespace. We'll also clear PVC, no resource found, pv. Okay. So kubectl delete all --all removes the pod, services and deployments, but it does not delete the persistent volumes or persistent volume claims. That's why we explicitly remove them too. This way no old resources interfere with our demo. So let's verify. Kubectl get pods svc deployments. We started the clean MiniKube cluster, so nothing from earlier demo interfere. This is an optional step, but I usually do it so my environment is clean before showing you the demo. If you have already done, or if you already have the fresh cluster, you can skip this step. Now let's create a pod manually without a replica set. kubectl run my pod. Image we will use Nginx. Restart equals to never. Kubectl get pods. Container is getting created. Here I am creating a single pod named my pod, which is running the Nginx image. The flag --restart equals to never tells the Kubernetes not to manage it with a replica set or a deployment. It's just a standalone pod. We can verify. Once again, you can see the pod is running, which has a name my pod, and the status is running. Now let's delete the pod and see what happens. Kubectl delete pod my pod. So kubectl get pods. Now I have deleted this pod. Since it's not managed by a replica set, it won't come back. Notice after deleting, if we check again, the pod is gone. This shows the standalone pod do not auto recover. Now let's create a replica set with a 3 pod. I will create a directory first. mkdir replica set. Let me create a file replicaset.yaml API version app equals to v1. Use kind as a replica set. Metadata name equals to my apps-rs. Spec I will give replicas will be 3. Selectors match labels app equals to my app, and we'll use template. My app, okay, and in template let's use spec containers. Container, use the image as Nginx. Save this, like kubectl apply -f replica set version v1. specs.selector.match labels. Okay. So the string decoding error, one more error it is having. Let's recheck. Match labels. Now I'm creating a replica set called myapps-rs. We asked for 3 replicas, so Kubernetes will ensure 3 pods are running with Nginx container. Let's verify kubectl get pods, kubectl get a replica set. It's 3. You will see 3 pods created automatically and the replica set shows 3 by 3. And now let's delete one of the pod and watch auto healing. Kubectl get pods, kubectl delete pod. I will use this first pod. So here you can see I have deleted one pod and ReplicaSet created a new pod 5 seconds ago. Now I have deleted one of the pod that belongs to a replica set. The replica set immediately notices and spin up a replacement pod to maintain 3. This demonstrates the self-healing features. Now let's scale the replica set. Kubectl get rs, kubectl scale rs, my apps -rs. This name we need to use. -replicas equals to 5. Let's scale up the replica set from 3 to 5. Kubernetes will create 2 new pods to match the desired state. You will see 5 pods running now. This shows how easy scaling with replica set. Now let's clean up. Kubectl delete rs. I will use my app rs. The earlier ready state was 1 by 1, now it's getting deleted. By deleting the replica set, notice that when the replica set is removed, all pods managed by it are also removed automatically. So you just saw it in action. Standalone pods don't recover on their own, but replica set ensures recovery and scaling. Let's summarize everything we learned in today's session. First, we talked about pods. Pods are basically the smallest unit in Kubernetes and they are used to run your application container. Next, we covered a replica set. This makes sure that your pod are always running. So if one pod fails, another one is automatically created to replace it. And finally, the benefits. Using pods and replica set together gives you high availability and make it easy to scale your application. I have added the YAML files in the description so you can try this out yourself. Thanks a lot for watching. Don't forget to like this video and subscribe for more tutorials. Thanks for watching.